Chapter 16, Chicago Pile 1. In scientific circles in the United States and the world over, not all scientists were thrilled with the idea of using science as a means for developing a bomb. Many hoped that some sort of technical glitch would prevent a chain reaction from happening and in turn would prevent the building of an atomic weapon. But Enrico Fermi wished the opposite, and one night in December of 1942, he conducted an experiment beneath the stands of the University of Chicago Stadium to prove once and for all that it could be done, that is, that his hopes could be realized. Arthur Compton had originally wanted to test the test to take place in an area about 20 miles southwest of Chicago in the Argonne Forest, named for the forest of Argonne in France, where the United States troops had fought during World War I. The forest was heavily wooded with oak trees and had a log cabin that had once housed a Girl Scout club. The site was a pretty one, with trees flanking the lake that iced over into the winter. Colorful flowers shooting up from the ground every spring and summer, and foliage changing hues as the summer days ended. Construction for the experiment started in earnest and continued at a frantic pace. However, by the time the scientists had collected enough graphite and uranium for the chain reaction, construction had not been completed. This posed a problem, as speed and efficiency were required, so it was decided that the experiment should be tried a little closer to home. The University of Chicago's Stagg Field was chosen as the spot. Its stands in the underbelly of the stadium would have to work. Compton agreed that Stagg Field's double squash court would be a suitable site. Despite its being in the middle of a stadium at the University of Chicago and the university itself being in the center of a populated area, they did not expect trouble. Compton initially wondered if they should ask the president of the university for permission, but he did not think it was necessary. No one, aside from them, needed to know about their doings. On November 4th, they prepared the double squash court under the west stands of Stagg Field. The layers of graphite matrix were to be the supporting graphite for 4 by 6 inch timbers, which were carefully laid out. They performed this work very slowly and carefully, and by November 20th, they had added a 15th layer of graphite. Within each layer, a hole was left for a zip rod, a long wooden stick wrapped in cadmium that would absorb neutrons. The rod was meant to be pulled out and dropped in with the help of a rope. If the rope snapped, the rod would fall and stop the chain reaction. If the rod was pulled out and held for a moment just before the pile started up again, or if it was let go, gravity would do the job and the rod would fall back into the pile. Walter Zinn, another scientist in Fermi's laboratory, was in charge of this whole operation, and he felt the weight of responsibility. In addition to the zip rod, another wooden stick encased in cadmium had been added that could be manipulated by hand. There was an emergency bell that would ring if the boron trifluoride counters and ion chambers rose to a potentially dangerous level. The morning of the test was frigid. Leona and Fermi stepped outside the slightly snow-covered grounds of the university buildings and onto the field, icy particles crunching beneath their feet. She held on to a thick pile of papers with Fermi's calculations and plans depicting the experiments reaching the critical points. Everything had been well thought out, with each person knowing his or her assignments. They made sure to have nearby a vat of concentrated nitrate solution, which could be used to douse the graphite pile in case of emergency, stopping the chain reaction. However, despite all their preparations, they felt agitated, as they knew that if the experiment worked, the repercussions would be historic. Everyone was there as Leona, in a fairly loud voice, began to read the counts of the boron trifluoride counter. 2, 2, 3, 1. It was the manner of counting Enrico Fermi had designated, in 10-second intervals, and which she had memorized. No one spoke in the darkness. Leona could hear her own teeth chattering from the cold, although she guessed the rattling was also partially due to the excitement. There was nothing normal about the situation, and they knew it. To quiet their nerves, some of them counted backwards. George Wheel, one of the scientists present, pulled out the last control rod, plucking it out foot by foot as Fermi had instructed him to do. Fermi, at that particular moment, was on the stands above them, watching the whole operation and making additional calculations on the spot, while Leona kept watch on the monitors. Those present felt their anxiety growing by the minute, until finally Walter Zinn released the rope, the rod falling into the reactor, and the control rod was pushed in, the intensity of the neutrons dropping quickly. The chain reaction was thus stopped. Then it was started again, and everything operated normally. December 2nd, 1942, would go down in history as the first time a chain reaction had occurred. Sure, the spark had been only enough to power a light bulb, but that was not important. What was important was the fact that it had worked. Leona had spent 2 months beneath the stands of Stagg Field preparing for the first chain reaction, and its success made her giddy. Fermi had instructed her to read everything she could about the latest developments on plutonium production reactors. She had also prepared the counters for the graphite piles. Now her work had come to fruition. She felt giddy with pride. Leona and the others started locking every control mechanism and turning off the power supply. They were about to don their overcoats to walk back to the laboratories when Eugene Wigner, another scientist in the Fermi group, who was carrying a bottle of Chianti wine, stopped them. Given that Fermi was Italian, Wigner thought Chianti was a fine choice to commemorate the occasion. He had also found some minuscule paper cups, and in those he managed to pour some wine for the nearly 24 people present. Each person then signed his or her name on the bottle. Eugene Wigner later wrote, "The success of the experiment, its accomplishment, had a deep impact on us. For some time we had known that we were about to unlock a giant. Still, we could not escape an eerie feeling when we knew we had actually done it. We felt, as I presume everyone feels who has done something he knows will have very far-reaching consequences, which he cannot foresee." Leona and Fermi returned to the university's laboratory, their feet echoing loudly on the frozen ground, the temperature having dropped below zero. They said little. Leona didn't know what Fermi was thinking, and she didn't want to ask. However, she could speculate. She imagined his thoughts were just as heavy as hers. "Of course, the Germans have already made a chain reaction because we have," she told herself, "and they have been ahead until now. When do we get as scared as we ought to and work harder?" No one knew how far the Germans were in their own development of the bomb, but just like every other scientist, Leona feared that the Americans were falling behind. However, she didn't share these thoughts with Fermi. Arriving near the laboratory, they went their separate ways. Completing the experiment beneath the stands of the University of Chicago had seemed like a good idea. Fermi had decided to use several neutron-absorbing cadmium rods. As he slowly inserted those into the pile, the fission chain reaction stopped. If he wanted to get it to start again, he needed to pull out a rod again. This action was performed very, very slowly. Of his success, Fermi had this to say. The first pile had no device built in to remove the heat provided by the reaction, and it was not provided with any shield to absorb the radiations produced by the fission process. For these reasons, it could be operated only at the nominal power, which never exceeded 200 watts. 200 watts will illuminate a couple of light bulbs. It proved, however, 2 points: that the chain reaction with graphite and natural uranium was possible, and that it was very easily controllable. In mid-1942, Zinn and his assistants removed the graphite and uranium assembly from beneath the stands of Stagg Field and transferred them to the Argonne Forest, which was still a forested lot when they began dismantling the original pile. Along with the pile went pertinent instruments, pliers, files, and whatever else was needed or that Leona Woods had managed to steal from other departments. The scientists felt a lot of pressure at Argonne. They knew the new pile was now nicknamed CP2. The new laboratory contained a large machine shop for construction, a chemistry shop for experiments, and a long room that worked as an office. The 2 dormitories were 2 wide-open spaces that were not used efficiently, Leona thought, as one was the dominion of all the men involved in the project. and the other one was entirely her own, as she was the only woman on staff. Between the two dormitories was a bathroom with a shower and a toilet, which they all shared, to her despair. The men were not a tidy bunch, especially when they did their laundry and hung it in the bathroom. John Marshall made a habit of taking his damp underwear into Leona's dormitory, where there was more space. On the first floor of the dormitories were the offices of Enrico Fermi and Walter Zinn. The Argonne Forest was part of the Cook County Forest Preserve and was managed by a forest ranger and a handful of guards who were less than thrilled with their jobs. But every evening they seemed to take pleasure in cleaning their shotguns, something they practiced with a delicacy that bordered on deference. On one occasion, one of the guards accidentally discharged a round of pellets towards the offices. Fortunately, no one was working at the moment. Following her work in the Argonne Forest, Leona was sent to Hanford, Washington, to start up the plutonium production reactors. Hanford was a small village located at a bend in the Columbia River, downriver from the Grand Coulee Dam. For many years, it had served as a center for several ranchers who had built their homes alongside the Columbia's banks. The river, and more important, the dam, played a significant role in the government's decision to choose that spot to build the plutonium production reactors. The dam made available more than 300 megawatts of electricity to power the construction, the pumps, and the city that would eventually spring up around the facility. And the reactor's cooling system required nearly 75,000 gallons of fresh water per minute, for which the Columbia River was ideally suited. Surrounding the few ranches, there was only a vastness, a great empty space. It would be no trouble at all, officials felt, to lease some 500,000 acres. And those few ranchers who would be displaced would move elsewhere. When Leona arrived, she could see only empty land, the low hills across the Columbia River, and to the west, the foothills of Yakima Ridge, flanking the Cascade Ranch. There was an abundance of sagebrush, and she frequently spotted coyotes and rabbits. Sometimes she liked to watch flocks of geese as they flew across the Columbia and then returned at night, small dots speckling the sky. Because such a vast desert surrounded Hanford, they were often plagued by sandstorms. The wind blew sand in their faces, covering their bodies, getting in their hair and eyes. Storms could last 2 or 3 days and had the power to halt production. The project required not only scientists and engineers, but also the help of hundreds and eventually tens of thousands of other workers. This gave job seekers from different walks of life the opportunity to be part of one of the most secret projects ever created. It was a mammoth operation. Pipe fitters arrived daily, as did plumbers, bricklayers, canteen workers, and landscapers. Most of them were housed and worked in a camp made of temporary wood frame buildings. The project brought extraordinary wealth to the area, and thousands of people arrived every day to work. By 1944, at the height of Hanford's activity, the workforce hovered around 51,000 people, and of those, nearly 10% were women. The whole facility was built in a great hurry, the area bustling with carpenters, electricians, and everybody else arriving on the Northern Pacific Railroad. They mixed the sand and gravel already on the spot with cement and water to make concrete to build the reactor buildings along the basins that would hold the cooling water. That water would stay there until the last trace of radioactivity was present, and then it would be dumped back into the Columbia River. The first reactor at Hanford became known as the B reactor, and it was completed and operating in September of 1944. Around the same time, other plants were finished too, such as the ones needed to extract plutonium from irradiated slugs. It took less than a year to complete construction for the entire Hanford operation, and what rose in the Washington state desert was a gigantic complex that functioned completely on its own by early 1945. And soon enough, Hanford was able to produce the amount of plutonium that was needed for the July 1945 Trinity test in New Mexico, as well as for the Nagasaki bomb. Enrico Fermi arrived at Hanford almost 2 weeks before the first plutonium reactor started up. When the time came to fuel up the large reactor, Leona and Fermi walked quietly around the control room, checking every knob, looking at graphs and charts, trying to appease bosses who had come in for the momentous occasion. The slow, easy movement of pulling out of rods step by step, one by one, began. It was not unlike the experiment back at Stagfield. However, this was of a much larger scale, and the witnesses were tough employers whose expectations were much greater: the military and the government. The reactor was performing as it should have. Once again, all the scientists knew that they were supposed to be what they were supposed to be doing, and went around the room controlling outlets, inspecting wires, taking readings, and talking to one another in whispers, as if fearing the reactors would hear them and decide to act capriciously. But then something odd happened, and Leona appeared to be one of the last to find out that there was something wrong with the apparatus. The radioactivity in the pile was slowing down, decreasing beat by beat, which was not supposed to happen. Slowly, the power dropped until it died down completely. The initial excitement in the control room was now gone, replaced by an overwhelming sense of doom. No one said anything for a few moments. Leona had noticed the peculiar drop. She admitted to Fermi. It had been linear. Maybe a water leak had caused it, and it wasn't necessarily anything to do with radioactivity. Fermi agreed to have some testing done, but he wanted to wait until the morning, as he suspected that the problem was not as grave as they thought. Overnight, as one of the operators kept watch on the apparatus, he saw the pile restart and then go through the same process of shutting down moments later. It repeated the operation a second time. For several days, operators, scientists, technicians, electricians, engineers, and everyone else involved in the construction of the pile watched as the apparatus shut down on its own, then restarted again. They made calculations, looked at possibilities, and tried to figure out what could possibly be happening. Finally, Fermi calculated that if all the extra holes of the reactors were loaded with uranium slugs, the reactors would have enough radioactivity for a successful operation. As indeed it did. There was no more shutting down. The reactors performed successfully, producing the first patches of plutonium, which were then shipped off to Los Alamos, where the makings of the atomic bomb were already underway. Leona Woods married John Marshall in July of 1943 and soon thereafter became pregnant. She moved around the building in large overalls and oversized denim jackets, which were her usual work clothes. Her pockets often contained pens, papers, pliers, notebooks, and rulers, all of which provided additional bulk, and for months her colleagues did not realize that she was pregnant. She arrived early in the morning by bus, one of those Army-issued ones that had neither heat nor other comforts. It was painted blue for some reason, and the color made her queasy. It was not an easy trip, particularly for a pregnant woman. Her morning included the rough ride to the laboratory and a quick dash to the bathroom to vomit, and then she headed to her office to begin her day. The laboratory was nearly 30 miles away from the hospital where she was planning to give birth. Fermi worried that she would not be able to reach medical help in time if her labor came on suddenly. Initially, he did not tell Leona, but he had asked his wife, Laura, about childbirth lessons, just in case he had to deliver Leona's baby himself. When Leona found out, she vowed that this would be an experiment he would not get to perform, something that she suspected he would be highly disappointed about. Neither one had to be worried. As it turned out, while at home one night, she felt ill, her blood pressure spiked, and she was rushed to the hospital. 2 days later, she left with a baby. While in the hospital, she recalled a time when she and a coworker were irradiated with a large dose of gamma rays. Her white blood cells quickly dropped to half the normal level, although at the time she hadn't been worried. She had actually been more concerned with any leaks that might have occurred in the experiments. None had happened, and her work was later completed properly. She had continued to feel tired for a while and sought medical aid from the doctors at the Met Lab, but rather than helping her, they had lectured her about the proper duties of a woman and how many egg cells a female possessed. Did Leona know that she had only a certain number of good eggs and that they could be easily destroyed by the radiation? She would never be able to procreate if she went down this path, the doctors told her, adding that perhaps she should have chosen a different career. She was left feeling ashamed and dumbfounded. Even though her colleague Willard Libby was irradiated in the same incident, she later learned that he had not been lectured about his sperm count. But now she had her baby, proof enough that the radiation had caused her no harm. Leona returned to work shortly after the birth of her son, as her mother was willing to help take care of the child, the household duties, and whatever else needed to be done to keep Leona's house running smoothly. The older woman practically ran Leona's domestic life, which Leona did not mind. Her expertise was needed, she knew, and she was eager to get back to work.